Okay, so we need to review the exponent rules real quick. And so we recognize that if we have x squared times x squared, that's the same thing as x times x times x times x. And so we end up with x to the fourth. Or we could have x cubed times x to the fourth, and that's x times x times x. That takes care of this x cubed times x times x times x times x, which takes care of x to the fourth, and that gives you x to the seventh. Now notice in both of those equations we could have simplified that whole process because the rule says that a to the m times a to the n equals a to the m plus n. So all that says is that when bases are multiplied together, here x is multiplied to the x, and they have exponents, we just add the exponents together. And that's what we did. 3 plus 4 equals 7, and 2 plus 2 equals 4. Okay, so that's that rule. Now we can also look at the division rule where we have x to the third divided by x to the fourth. And when we do that, we'll notice that we have x times x times x in the numerator, x times x times x times x in the denominator. And knowing that we can divide out factors, x divided by x is 1, x divided by x is 1, and x divided by x is 1, that leaves us with 1 divided by x. And so we also know that 1 divided by x can also be written as x to the negative 1. So when we divide exponents, we actually subtract, when we divide bases, we subtract the exponents, and 3 minus 4 equals negative 1, which is what we get for that exponent. Okay, so here in this problem we're doing the base raised to an additional exponent. So we have x cubed squared. So x cubed squared is just x cubed times x cubed. And then we know that x cubed is x times x times x times x times x times x, which is just x to the sixth. So we can also look at x squared to the fourth, and that's just x squared 4 times. And so then we also know that x squared is x times x. So we have that 4 times, and so we end up with x to the 8th. So you'll notice that the rule here, after we look at all of this, the rule here is that a to the m raised to the n is actually a to the m times n. So here, when we look at our two exponents, one raised to the other, 3 times 2 is 6, which is exactly what we get. On this equation, on this problem, we have 2 and 4. 2 times 4 is 8, and that's what we end up there. So that's that particular rule. Okay, and then the last rule that we have to deal with is the zero exponent. And the zero exponent just always gives us a value of 1. So it doesn't matter what the base is. So the base could be 12 raised to the 0 power is just 1. Because you remember the quotient problem says that if we have a to the 1 over a to the 1, we would subtract those exponents, and when we subtract those exponents we get a to the 1 minus 1, which is a to the 0. But we also know that when we have a numerator that's the same as the denominator, that just equals 1. So that's where all of this comes from. So anything raised to the 0 power just equals 1. Okay, so we did the simple exponents. Now we need to look at some of the more complicated exponents. X to the 1/2. Okay, so the 1/2 doesn't really mean we're taking half of anything. The 1/2 is just a representation of a radical. So this is the same thing as the square root of x. So we need to also recognize that we could have x to the 1/3, which is simply the cube root of x. We could also have something written like x to the 2/5, which is actually the 5th root of x squared. So knowing all of that, what we need to consider is that the numerator of the fraction is the exponent of the base, and the denominator of the fraction is the root of the radical that we're looking for. Okay, so it's just a way of representing radical expressions through the use of exponents. That's all it is. So I'm going to give you a couple of problems and see if you can figure out what they are. All right, here are your problems. All you're going to do is rewrite them in radical form. So write these down, stop the video, do the problems, and resume to see the answers. Okay, so here are the answers. Okay, so here are a little bit more complicated problems. So you're going to take these problems, simplify them, and then write them in radical form. So I'm going to leave you to it and see if you can do it, and then resume the video to see what the answers are. Okay, so here are the answers, and you'll notice in number 1, we used just the basic understanding that you multiply exponents when they're raised, when an exponent is raised to another exponent. So when we multiply 1/2 times 3, we get 3/2. So x to the 3/2, which actually is just the square root, because the denominator determines whatever the root is. So it's the square root of x to the 3rd, because the numerator identifies the exponent of your base. Okay, on the second one, we have a base times a base, and so we add the exponents, and I did not add those exponents. I multiplied those exponents. So it should be 2 1/3, which is the same thing as 7/3, and so my answer is actually wrong. So this should be a 7 here, and that would make this a 7 under there. Because remember, we have to add the exponents when we are taking a base and multiplying them together. Okay? And then on the third one is kind of tricky too, because we have to recognize that we have a division problem, and we normally would do 3/4 minus 1, because remember there's an understood 1 down here. But because when we subtract 1 from 3/4, we get a negative 1/4, and remember, a negative exponent means to put it in the other location, so therefore we had to put it in the denominator. That gives us the 4th root of x in the denominator, and we don't ever leave radicals in the denominator. So we actually can't simplify the exponents, so we go right back to the original equation and just rewrite the numerator into radical form, and we get this for an answer. Okay, here's the last 3 problems to see if you can work these out. Again, apply your exponent rules and see how it works out with your radicals. All right, and here's the answers to those 3 problems. So you'll notice up here there isn't a radical in the end, because 2/3 times 6 actually just comes out to 4. So since we get a 4 there, there is not going to be a radical. It's just x to the 4th. Great. All right, number 2, we have to add the exponents. So 1/4 plus 1 gives us 1 1/4, but that's not going to do us any good. We have to turn it into an improper fraction, which is the same thing as 5 divided by 4, because remember 1 is 4/4 plus 1/4 gives us 5/4. So we have x to the 5/4, which means that we're going to put it in this situation with the radical, using the radical symbol. All right, and then here we have x squared divided by x to the 1/4, which means we're going to take 2 and subtract 1/4 from it. When we do that, we get 1 3/4. But we can't use that as an exponent. We want to make it into a fraction. So 1 is 4 divided by 4 plus 3/4 gives us 7/4. So x to the 7/4. And when we put it in radical form, we have the 4th root of x to the 7th. And that's exponents using rational exponents.